Welcome back, guys, to another lead code session. In this session, we'll be doing the lead code question that I have been being tortured by, which is product of array except itself, and then we're doing some Golang as promised for to you guys. So while I was out doing stuff that people do in their life, I actually figured out how to solve this question. And the way I did was I watched the neat code video and it did not hit me, but when I went down to do some random shit, I actually figured it out the way he wanted to do. So let's see how will we do this actually. So what we will do is we'll assume that we have A, B, and we'll have C. And our output array is as of now contains 1. So I'll just contain it as nothing, but it contains 1. Now our desired outcome is over here we'll have B into C, over here we'll have A into C, and over here we'll have A into B. Now we need to get this in O of n time complexity without using any extra space. So O of 1 space complexity, the output array does not count. So how do we do this? So the way, the neat code does it, now it hits, is we create, so what we do is in this array itself, jahan pe, this array that we create for the output, we first start scanning this. Now the the result for that index will be all the elements multiplication of the prefix into all the elements and its postfix. So we can have a variable that says postfix, and the postfix for this is 1. We do this, right? The postfix is 1, so prefix is 1. We come here. Now for B, now after we go over this, we'll add A, because now the prefix of this is A, and now we'll add A over here. Then we come over here and then we do into B, and now A into B. Now we do this is prefix, now we do postfix. Now postfix of C is 1, right? Postfix, so we do nothing. We come over here, now the postfix of this is C, right? So we do C over here, and then the postfix will become pretty much whatever we had C into B, and so B into C will come. Now I don't know if you guys understood a lot from that, but let's code this up. You guys will understand exactly how this works. So we'll have prefix 1, and I think the way, because I'm doing this because I have to do 2 passes regardless, so we'll do prefix postfix 1 comma 1, right? And so the first pass for getting prefix, and so the way we'll pass through this is we'll just go over here, go over here, go over here. So we'll just say for I in range of L, and now we'll pass through this. So what we'll do is nums except I is equal to, actually I is actually equal to nums except is equal to prefix, and prefix is equal to prefix into, because now it will be looping back over there, prefix is equal to nums I. Right, so if that makes sense, what exactly opens over here is when we come to A, a prefix contains 1. Now, in our actual array that's output, it will have 1 over here, and then our prefix will become prefix into nums 1, which is A. Now we come to B. B ke jagah, we'll have B nums except is equal to prefix that will contain A, and now prefix becomes A into B. Now we'll come to C, and C will come turn A into B. So that works amazing. We come to second pass for getting postfix. Same thing for I in range of L. And the way we do this is a bit interesting because we want to loop opposite. So because we want to start from, let's say, because 0 1 2, and so we want to start from here. So I think the way you do that, loop reverse order in Python using if loop, for loop. If is a conditional statement, for loop. No, I mean in terms of numbers. So over here we do in range. So start, stop, start, stop. Interesting. Let me just open up VS Code real quick. Um, let's do this example. I just wanted to go 3. I just wanted to be, so let's say we have length is equal to 3. The index we really care about is 210. So let's say if I do for I in the range of, how will this work? 3, 2, 1. That's not exactly how I want this to be. Was this wouldn't work actually, to be honest. This wouldn't work, right? Okay, मैं समझ गया what to do. So this would be 3 minus 1, and we would end with 0, and yeah, 2, 1. We want to end with minus 1 because that will be exclusive. Wouldn't consider that. Sorry. Yeah, so this will work. 2, 1, 0. So what we do over here is we will do L minus 1, minus 1, minus 1, and yeah. Okay, let me just format this code real quick. Okay, so L minus 1, so it will go to 1. Okay. So now we'll do nums except I is equal to so nums except I. So over here we were pretty much overriding this, as you could see. Now when we come to C, over here what we want to do is whatever now that contains, we would just do of this of prefix. Sorry, postfix. My bad. Postfix, right? Because over here the postfix of this is 1, so यहाँ पे we'll just into 1. Now once we come over here, we will set our postfix to be equal to whatever num's value is. So now postfix of num will contain um, is this correct though? Yeah, it wouldn't do that. That's actually kind of dumb. It will do something like this, right? So now the postfix will contain 1 into C. Now we do over here, and so yeah, basically this wouldn't be here, and we do A into C. As you can see, that happens, and then the postfix becomes whatever that nums contains. The postfix now becomes nums I, so because it becomes B into C, and then we do that, and then we return nums except. Okay, I think this should work. Yeah, so it runs all the time. Nums except is equal to whatever the prefix is, and then going forward the prefix becomes whatever that num we had. Yeah, so that makes sense. Nums except, because now we have values inside this, will be into the postfix, and then postfix will keep on adding on to that. And yeah, so this should work. Okay, so that does work. And yeah, so we are pretty much on 8.6. I guess I'll just what the hell just happened? Okay, that was crazy. What the hell just happened? Wow, as you can see, I was downloading all the thumbnails. This is interesting. Yeah, anyway, so and yeah, so I'll just remove, actually just have another tab over here, paste. Actually, what the hell? Um, can you compress this? How much? Right, so that is one of those solutions done and dusted. I will have to revise this tomorrow, even though this thing does I do understand it now how this works, and it does make sense to me. Like, okay, that is how you do it in O of um in O of one space complexity and in O of n time complexity, and yeah, I think that's good enough. I think for us to at the moment, right? Yeah, so I think that's all. I don't have to do anything much about it. I will now open Golang, and we'll get back to doing some Golang. So see you in, I guess, few seconds, but for you it'll be instantaneous. So we're back, and so I've loaded up tool of Go, and this is like I'm kind of scared now because I have not yet solved this, and it is scary. Let's see if we can solve this. So I guess let's start by reading the. Why can't I just remove this? Your progress will be dropped. What do you mean? Can I can I just remove this, please? Because I like this is taking up so much real estate. Anyhow, can I adjust font size? Yeah, I think that's much. I think that big enough is important. Stretch. Okay. Anyhow, as a way to play with functions and loops, let's implement a square root function given a number x. I may have to pull up Excali draw for this one. Yeah, I think I have to pull up Excali draw. Just give me a moment. Again, it'll be instantaneous for you. Again, we're back with Excali draw, And I think we'll map this question out. So let's see what the question is. As a way to play with functions and loops, let's implement a square root function. Given a number x, we want to find the number z for which z square is most nearly x. So given a number x, we want to find z for which z square is equal to x. So z is nothing but the square root of x essentially. Computers typically compute the square root of x using a loop starting with some guess z. We can adjust z based on how close z square is to x, producing a better guess. Repeating this adjustment makes the based on how okay, repeating this adjustments makes the guess better and better until reach equals as close enough to the actual square root as can be. Implement this in the function square root provided a decent starting guess for z is no matter what the input to begin with. Repeat the calculation 10 times and print z along the way. See how close you get to the answer for various values of x and how quickly the guess improves. Hint: to declare and initialize. Note: the next change the loop condition stop once the value has stopped changing or only changes by a very small amount. See if that's more or fewer than 10 iterations. Try another initial guesses. Again, for z, okay. Okay, so what it's trying to say is instead of trying to start z with 1, why don't you try checking it with x by 2, right? So let's have this common sense being over here. Let's just say if we have x to be 1, z has to be the square root of 1, so that is 1. Let's say if we have x is equal to 2, we want z to be square root of 2, which is around 1 point something. The funny thing is, why would you want z to start by x? Because again, we know for a fact the square root of something will be smaller than the number, assuming that the number is an int, because in the float case it becomes bigger. But if I take 2, if I take 2 by 2, I get 1. If I get 3, if I get this, I get 1.5. And square root of 3 is 1.7 something, right? If I do 4 by 2, well, the square root of this is essentially 2. And if I do 5, let's see what the square root of 5 is. So we do 5 by 2, which is 2.5. Right, so again, for this is opposite, because this is 2.2 and this is 2.5, which is interesting. But let's just try to have fun around this concept. And so we have a counter variable, how to run a loop for some what's the go way of doing that? Okay, so it's this way. Cool. So I could do something like yeah, so I could do something like 0, um, I less than 10, I plus plus. Okay, and okay, so we're starting z off by this. Well, we could start off z by, okay, I mean, sure. And so this is what z is, building up to. And then we obviously have to return z. Can't just, do that and not return it. Right. Let me just remove all that knowledge over here. This is much more cleaner, right? This is much more cleaner. And let's run tasks.go. Let's see what happens. This is exercise. Okay, this is not the exercise loop and functions. Yes, it does take a while to run for some reason on my system. I don't know whether this is a common occurrence, but I guess Go performance optimization. This is again. Is this thing okay? Okay, so you can see the current value starts from 1.5. Okay, because this is it's a after we calculate this. It's gonna take a while to do that, but let's see. Okay, so initially it's 1, then it becomes 1.5, then it becomes, and then at some point it stops changing. So this changes. changes a bit. Yeah, so it just keeps looping for a while and then finally changes this um, okay. Again, okay, let's do something like this. Let's start with this, and let's do something like fnt dot println. Um, that does that change absolutely nothing for what I wrote, but anyhow, whatever makes you, you know. Okay, what the hell? Oh, my bad. Pff, I'm so bad. Z. Yeah, okay, my bad. That's fine. Yeah. Okay, so when Z is 1, we get this, and then we do print this out. I don't know why, but you see that at the end, this is the result. But we print out something else. We print out this, which is, yeah, I mean, this does some top level representation. Anyhow, it works or it doesn't. Okay, I was like, oh wow, it works. Anyhow, what was that? Okay, let's look at the logs. Okay, compare outputs. Uh, Again, one thing I don't understand is the people who made this question, like, what were they thinking? I mean, like, actually, not in like a, I guess, in a dumb way, but I'm just saying. Okay, let's just close this out for a moment, and let's say let's make it start with x by 2. Let's just for fun's sake, let's do it by x by 2. Okay, and let's check the result now because I'm assuming somehow it's gonna. What are we doing? Okay, let me look at the author's result. I don't know what they're doing. Const x mine there's. Bro, are you seeing this? Huh, crazy, crazy, bhai. Anyhow, const x to mine theirs square root, and they import one from the math wala and mine theirs. This is what he was printing, and I was over here wondering what am I doing wrong. Ha, crazy. Wow. ये कैसा difference है? What difference is this, bro? Ay, ay, ay. Again, I don't know what the author wants me to do. Um, Again, okay. Let me look at the author's solution. I want to see the author's solution, and I can't look at its solution. Okay, let's see what the author does. So, author does var delta, which God knows what this is. He takes z to be x, weird, and he takes n. Now he says, hmm, he does n minus z. This is some voodoo magic, chat. This is some voodoo magic. I don't know what this voodoo magic is, right? But I'm not gonna do that. And sadly, we will have to get past it. And this, if I spend too long in this, I'll be wasting a lot of my time. So I'll just go ahead. We will do something in the future. Trust me. A switch statement is a shorter way of to write a sequence of it runs first the case whose branch in the switch segment. Um, okay, let's see what this is. So fnt print go runs on. So we do switch and we do something called OS, which is turns out to be a string, and we do runtime, which is I'm assuming some part of, and goose. Goose is the running program's operating system, one of Java and filter learning and so on to which okay, and this weird syntax we do case and this is how they do it default. So okay, this is pretty similar to C and all, but as the thing that in C and all you have to do something called break. But as I said, Go does not, Go does not do it. It provides automatically, which is good because it becomes redundant a lot. Yeah, so that's good. Let's run this ctd go run tasks.go. Go runs on Windows. Yeah. So, I mean, yeah, this is pretty much similar to how, again, I don't know what this syntax is. Again, why are we doing it like this? Can I do something like this? Is it like this? Again, Go's formatter is, it's interesting. Let's just say switch evaluation order. Switch statements evaluate case from top to bottom, stopping when a case succeeds. Okay, yeah, I guess that's how it works, right? Does not call. Okay, so if we do switch I, case does not call if I is equal to 0. No, time and go playground always appears start this value more significance is left to the user. Yeah, I know about that. I think this is when go was at least something, and maybe it could be. But anyhow, when's Saturday? So it takes today, which turns out to be time, that too of weekday. So time now weekday, and it says switch Saturday. Something is happening over here, and I would like to know what is happening. But feels like there's some fancy object related stuff is happening. Today seems to return which weekday it is. And so this is, says Saturday and says okay, today how many times I have to add so it equals to Saturday, which I think it's a weird way of doing this, but you know, anyhow. Switch with no condition. Switch without a condition is same as switch true. This construct can be a clean way to write long if then else chains. A clean way to write long if. Okay, so it's again it's similar to if else because if this case turns out to be true, it runs and the rest of them is not run. But okay, if this is not true, it comes over here, and this is pretty much like if else, but better way of writing this. And I agree with it. This is a better way of writing it. Uh, Something called defer. So a defer statement, a defer statement, defers the execution of a function until the surrounding function returns. This is dipping hands in concurrency. Differs the defer calls agreement evaluated immediately, but the function call is not executed. What is happening over here? Let me see. Interesting. So we have defer fmt print world. Okay. Um, Interesting. What is this defer keyword? Is it like as how join works in Java multi-threading? Well, if you say join on this thread, it will wait. A defer keyword is to delay the execution and call until the surrounding function call returns. Okay, so it's pretty much like join. You wait for its function call, then you start the execution. Again, it's making some sense. Um, so it's pretty much like finally. Stacking defers. Deferred function calls a push onto a stack. When the function returns its deferred calls are executed last in first out. Um, it has go tos. Okay, will I read through this? Yes. But right now we'll go into pointers because I love pointers. Nothing better than some. Is this? Wait a minute. Control Shift E, and this is more types. Let's go through pointers. Go has pointers. A pointer holds the memory address of a value. The type star t is a pointer to t. Its zero value is nil. Zero value, interesting. Var p in star. The AND operator generates a pointer to its operand, pretty much like how it does in C. In C, I recall writing something like if you have an in star pointer, you do something like this, like something like that. But over here, because everything is like that, so we do x star int nil, I guess, something like that. You know. Um, but yeah, sure. The star operator denotes the pointer's underlying value, so it's a dereference. This is known as dereferencing. Unlike C, Go has no pointer arithmetic. Thank God, because it's pretty much the only time you learn of pointer arithmetic is when you're dealing with array indexing. And it's like a cool party trick, but no one actually uses it, and everyone hates you for that. But anyhow, can I do something like var x in star is equal to nil? Nil. Can I do something like that? And it will say, well, unused variable, so just delete it. And yeah, but anyhow, let's actually run this. How do I run this? Control Shift E. It's pointers. Pointers. Go run tasks.go. So over here, this points. Again, we are. Okay, yeah. Is that my phone? Okay. I'm assuming this is also in some point var. Yeah. Okay. Again, if you have a strongly typed language, then why are you doing such things? Just do stuff like this. Why? If you have a strongly typed language, why do stuff like that? Like that just pisses me off. You know, like I'll just points to I. And let me just read that line because that is horrendous. And you see it works, right? FMT, and this is dereferencing the pointer. We change the dereferencing. Oh my god, that actually 21. Now it goes to J. Yeah, now I mean, I have used pointers a lot, and starting off, I hated it because I didn't understand it. But then, as you expose yourself, it makes sense. Struct. A struct is a collection of fields. Again, pretty much similar to how it works in C. Not much, I think, required. So we have type vertex. Again, in C, one of the things I do is type def struct and the struct name. So most of the time, you're doing node, you're making a linked list implementation. Um, something like that. But yeah, I think this approach is again, I like this approach. Yeah, sure. So we have type of vertex struct, and I don't know why this is capital. But yeah, so over here it seems like they're creating a vertex object and they're assigning its parameters. Okay, let's see what happens. CD structs, CD struct, go run tasks. क्या है नहीं क्या? So CD struct में run ही नहीं किया. Yeah, again, cat task dot go. That's not what I want to do. Again, why is it doing that? Guys, fix your ID. Like I'm clicking on this, but you guys waiting me, making me waste my time. Okay, 1 2. Yeah, that's pretty much like how we do in C, but the way you assign is different in C. Do dot X. Struct fields are accessing using a dot. Well, I mean that's C. Right, that's classic C. 4. Yeah, so that makes sense. We'll also change this to be like 5, and I'm so much used to the fmt dot print v dot y. So if you want that, done. Anyhow, pointers to structs. Struct fields can be accessed through a struct pointer to access the field x of a struct. When we have the struct pointer p, we could write this, which is pretty much exactly how you could pretty much do the same in C. However, the notation is cumbersome. Someone agreed. So the language permits us instead to just write it as p dot x without the explicit dereferencing. And in so that's not how you do it in C. In C you do like in C like p arrow x, which albeit, I mean, to be honest, this is fine. I have a issue that obviously if you look at, obviously the ID is very powerful to tell you that okay, this is actually a pointer to a vertex. So I could do something like var p pointer to vertex is equal to the address of that. But yeah, it would give the impression that maybe p is a vertex because you can do something like v dot x is equal to this by itself. But yeah, sure, I mean it's fine, and your ID will soon be able to pick up saying okay, well buddy, this is actually this, and x is a parameter in it, field of x in row. Wow, that's actually good. And we just print in that, so that's great. Interesting. Let me just see. Again, why are we doing like this? Just do it like this, bro. I mean, I think it's much more obvious that sense because you're explicitly stating the type, which is of struct vertex. Struct literals. A struct literal denotes a newly allocated struct value by what the hell did you say? A struct literal donates a newly allocated struct value by listing the value of its fields. So we have type, and again that's again one way of doing it. And we have var. We do v1, v2, v3, and we do even has type. Oh wow, we just pretty much make it up at point. And we pretty much fn print v1. No one did this, which I guess is optional, but it just creates more confusion down the line. Oh no, man, I'm a bit criticism. My English just keeps getting better. Go run task. Again, one thing I was worrying is will this actually print the address? Because in C, if you do this, it will actually print the address unless you purposefully dereference it. But in Go, I think they just do it automatically because they know no one is interested in the actual memory location. So I guess, yeah. So we have arrays. The type int t is an array of n values of type t. The expression declares a variable a as an array of 10 integers, and array's length is part of its type, so arrays cannot be resized. This seems limiting, but don't worry, Go provides a convenient way of working with arrays. It will introduce you slices. So var a to of string, which is perfect. And in C, this would be something like string, something like that. I think, yeah. But this is good. We have this fnt that print this over. I'm gonna see what happens over there. Um, okay, let me go see this. Cd arrays, and we go row run task. We say hello world. Oh, then it does not printed with that, which is interesting. If I do something like this, and if I try to run this again, this is a shorthand, which is I guess good. If you read from left to right, it gives you every information you need. Hello world. Cool. Uh, I mean, there's nothing much. This is just. I mean, this is guide. This is night. Slices. An array has fixed size. A slice, on the other hand, is a dynamically sized, flexible view into the elements of an array. In practice, slices are much more common than arrays. I would wonder why. The type is a slice with element of type T. A slice is formed by specifying two indices, a low and high bound separated by a colon. A slice is formed by specifying two indices. This selects a half open range. Bro, chill, bro. This is pretty much 0. Okay, so 1, 2, 3, so 3, 5, 7. Um, this selects in a half open range which includes the first but excludes the last one. The following expression creates slice which includes elements 1, 2, 3 of A. So pretty much 1, 2, 3. Yeah, 3, 5, 7 makes sense. I want to see what happens if we do 0, 1, 2, 3, 4, 5. I'm going to do something like 6. Okay, let me do something like 7. Oh, it gives me an error. It says, okay. But what happens if I still run it? Okay, it doesn't matter. Slices are like references to arrays. So as far as I understand, slices and Go are like dynamic arrays, right? Or am I wrong? An array has a fixed size. A slice on the other hand is dynamically sized, flexible view into the elements of an array. In practice, slices are much more common than arrays. Am I reading at the same thing again? Again, slice literals. A slice literal just like an array literal without the length. This is an array literal, and this creates the same array as above, then builds a slice that references it. Okay, what the hell is this syntax? What is this syntax? As far as I understand, it creates the struct and then puts. Oh, that's okay. That's interesting. Sorry, my bad. CD slice literals go run task. That's actually crazy. Slice defaults. When slicing, you may omit the higher or lower bounds to use their defaults instead. The default is 0 for the lower bound and the length of the slice. Yeah, so it includes everything. Yeah, so for this, the slice expressions are equivalent. Okay. Makes sense. Slice length and capacity. A slice has both length and capacity. The length of a slice is the number of elements it contains. The capacity of the slice is the number of elements in the underlying array, counting from the first element in the slice. The length and capacity of a slice can be obtained using an length and cap. You can extend a slice. Chat, I think I may have to stop over here. Not because I'm bored, certainly I'm very much excited to learn Go and I'm having a blast over here, but because I have to wake up in the morning early, right? So I have to sleep early, right? Because sleep is king. So thank you for joining again for another late night session, albeit a small session, but I guess we'll come back stronger tomorrow. And yeah, I think we did two things. We did the lead code question, which was bothering me, and some Go as I promised, and we'll continue with Go. We'll build certain projects with Go. I think that's the dream. Build projects with Go, or maybe do lead code with Go, to get a good hang of Go. I like the syntax. I like certain things of it. I dislike certain things, but not too much. But yeah, thank you guys for joining in and see you till the next one. Bye bye.